Flexible filament, a recent addition to the 3D printing family.
We wanted a flexible filament that was made from compostable certified raw materials without a sacrifice in quality.
Now we have WillowFlex, resilient when you need it.
Compostable when you're done. WillowFlex is made from compostable raw materials, certified in both the EU and the US.
The filament is printable at 175 Celsius at a rate of 60 millimeters per second.
And because it's made from natural materials, it has different qualities than other plastics. For instance, it's heat resistant above 100 degrees centigrade, which makes it perfect for your next cup of tea. It also retains its flexibility at negative 28 degrees centigrade. WillowFlex isn't harmful for users, and it isn't harmful to the environment. WillowFlex will be produced by trusted partners with over 30 years' experience in their field. After all, there's no better chemist than Mother Nature.
Hi, my name is Mark Sherman.
And I'm Gerald Gallazin.
We've discovered an opportunity to set a new standard of sustainability for 3D printing, an industry experiencing massive growth across the globe.
We started Dimension Polymers to make this technology more environmentally friendly. To do that, we developed the first professionally engineered 3D printing filament made from recycled plastic. 3D printing is the next manufacturing revolution. We can now create custom parts and sculptures in a quick and inexpensive manner. The growth rate of 3D printing is projected to be 20 to 30% over the next 5 years, making this an $8 billion industry by 2020.
Currently, all commercially manufactured 3D printing plastic is produced from virgin plastic. Since plastic is produced from petroleum, this process leaves behind greenhouse gases and waste that's harmful to the environment. When you factor in the projected growth of this technology over the next 5 years, it's clear there's going to be a huge environmental impact associated with 3D printing. Current demand for 3D printing plastic is estimated at 30 million pounds annually. That number is projected to reach 250 million pounds by 2020. This represents a growth rate of over 40% annually in the use of 3D printing plastic. It takes 1.8 kilograms of petroleum to produce a standard spool of 3D printing filament, producing 8 pounds of carbon emissions. This translates to the consumption of approximately 1.4 million barrels of oil and over 800 million pounds of carbon emissions into our environment every year.
We've developed an excellent solution to this problem. Let's recycle. Manufacturing 3D printing filament from recycled plastic generates less than 1/3 of the carbon emissions compared to virgin plastic. So why can't we make our own filament using recyclable materials found at home? Our reply to this question is quality and efficiency. In order to produce great prints and avoid hardware complications, 3D printing plastic must be sourced and manufactured to precise specifications, while still being subject to quality control standards and processes. The most popular way to currently use recycled material is the do-it-yourself filament extruder. However, this doesn't really address the issue on a large scale. What's efficient about purchasing a desktop extruder, sorting garbage, grinding up plastic, and making your own filament? On top of that, the filament may not even make good prints.
We've developed the first professionally engineered 3D printing filament made from recycled plastic that was on its way to the landfill. Using an A2LA accredited laboratory, we have formulated our material to ensure the highest quality product and consistency. The material has been thoroughly tested to ensure it meets or exceeds the performance of the highest quality plastic filaments currently on the market. The next step is to start producing the material on a larger scale.
For that, we need your help. By pledging funds to our campaign, it'll help keep the cost of manufacturing down so we can get this eco-friendly material into the hands of innovators like yourself.
We've got some great rewards lined up for our supporters, including the opportunity to receive some of the first filament produced.
So please, join us, and let's reclaim innovation together.
Here at Full Spectrum Laser, we've been making lasers for cutting and engraving for years. Now, we are making 3D printers using lasers that harden liquid resin layer by layer. Recently, millions of Blu-ray players have made low-cost near-UV laser diodes readily available. It also turns out that these lasers can precisely harden liquid resin to build a 3D printer. Our goal was to make a better 3D printer that anyone could own. "3D printers are amazing tools. By leveraging our previous laser experience, we are excited to make the next generation of affordable, high-quality 3D printers."
We wanted our printer fast, while still maintaining quality. We designed our printer to be over 10 times faster, at 3000 millimeters per second, by optimizing chemistry, as well as our laser-controlled electronics. Through several design revisions, we optimized the laser optics path to print objects up to 7 by 7 by 9 inches, and it also looks great on your desk.
Full Spectrum Laser specializes in advanced software and electronics, which we brought to our 3D printers. Prepare your models with our powerful, easy-to-use software. Add supports automatically or modify them manually. Easily connect over Ethernet, Wi-Fi, or USB. Because our printer has a full touchscreen computer, you can even browse pre-tested objects online in our built-in model store and print them directly from the printer without ever turning on your computer.
To deliver our rewards quickly, we've purchased most long lead time parts in advance, but we still need your help to expand our assembly line to accommodate our new 3D printers. Please support our project and help us create the next generation of 3D printers that are precise, reliable, and affordable to everyone.